Hi, and welcome back to PR Tech Talk. In this video, I'm going to connect an HW262 Multifunction Shield to an STM32 Nucleo-C031 development board. I purchased this shield online from Amazon, and I have seen similar boards priced between approximately 2 and 10 euros. Despite its low price, it includes 4 LEDs, 3 push buttons and a potentiometer, a buzzer and a 4-digit 7-segment display. Nucleo boards are intentionally quite minimal when it comes to onboard LEDs, buttons, displays and other peripherals. They are designed primarily as a flexible and affordable development platform. ST also offers discovery boards, which are generally more generously equipped with display, sensors, and other onboard hardware. Adding an inexpensive shield such as the HW262 is therefore a simple and affordable way to turn a Nucleo board into a more complete platform. However, there is an important electrical difference to consider. The HW262 was originally designed for a 5-volt Arduino board, while the STM32 Nucleo boards normally uses a 3.3 volt logic. That means that the shield should not simply be connected without first taking the appropriate measurements to adopt the voltage level. In an upcoming video, I will examine the individual functions in more detail. Let's get started. For the 5 volt to 3.3 volt considerations, we need to take a look into this area here. And I will zoom in so we can see a bit clearer what I've done. So this is the point. What you can see here is that I've made a very huge solder blob between the 3.3 and the 5 volt pin. So that is pin 1, 2, 3, 4 and 5. And on the other end, I have cut the pin 5. So there is normally a pin there. So I cut that one flush to the plastic, so there won't be any 5 volts on the board at all. And all the 3.3 volt that is coming from the Nucleo board is then connected to the 5 volt and sourcing every component on the board with 3.3 volts, making it safe to use with a Nucleo board. So that's quite an easy adoption to do. So here I now have the HW262 board, and with the modifications that I just shown. If I can get it in focus, yeah, you've seen what I did. And this is this Nucleo-C031C6 board. And we will just mate these two together. So that is our final result when we have mated these two together. And you can use this board with any Nucleo board that you would like to use. And here we have the C5 board, which then of course is used with the Cube MX2 platform. But we will use this C031 for these demonstrations and elaborations. Right, so here we have the board, and I have now connected it to the PC using this USB connector. And I have also now loaded the program into the Visual Studio Code, and we can then download and drive the code into the microcontroller. So what we now can see on the board itself, we have this 7-segment display, and it shows a value between 0 and 4095, which is the ADC value from this potentiometer that is measurement. And we can then change the measurement or the value on this one, and the display will then of course change. What we also can see is that these 4 LEDs here, when I go over 1000, I think it's, yeah, so over 1000 the first LED is turned on, and if I then go up to I think 2000, that is the next threshold. Yeah, so then we have the second LED turned on. What we more can see is on the terminal here, we can see the ADC value 2058 that correspond to the display on the module itself. What we also can see here on the terminal is the switches 1, 2, 3, and those are the one here. So if I now turn on the switch 1, I can see that that one is 1 and 2, and of course also number 3. We can also see the mode is changing. So if we now take a look on the display again, and we just turn on the first LED, we can now see that the mode is all LEDs. So all LEDs are now turned on. If we push the button 1, the push button 2, then we have the mode chase, then we have just the sequence of the LEDs. The third one then is, you can hear that there is a tone, and we then change the PWM frequency on the buzzer according to also to this potentiometer. So if I now push the switch and change the value, we change the tone. That means that we can actually play some very low quality music on it as well. I couldn't find any good schematics on it. I maybe looked not hard enough, so I created one here. Don't take this as the true story because there might be errors in it, or I can more or less guarantee that there are errors in the schematics, but I have made my best effort to make it correct. At least these are in the brackets. There you can see then according the pinouts on the STM32 microcontroller and the Arduino pins nomenclature here. Here you can see the buzzer, you can see the 4 LEDs, you can see the 3 switches and the reset switch, you can see the potentiometer, you can see the 4-segment LED here, you can see that one. You have a couple of decoupling capacitors. You have an external pin header that you can use for different stuff. I think that or these are for some UARTs. And then you have 4 3-pin headers with accordingly different pins on the microcontroller. So these are as I said in the brackets, those are the pins on the microcontroller, and these D5, D6, D9. That according to the Arduino pins that you can see there. I will put this also in GitHub so you can use it there. Make now a note that this is a modified for 3.3 volt operations, as I said, and I have then cut off the 5 volt pin and shortened the 5 and the 3.3 volt. So whenever there says 5 volt here, in reality that is 3.3 volt to make it work for the STM32. That completes our first demonstrations of the HW262 Multifunction Shield running on an STM32 Nucleo-C031C6 board. We have seen how this inexpensive Arduino shield can be adopted to use with the 3.3 volt logic of an STM32 development board. We have also tested its 4 LEDs, 3 push buttons, the potentiometer, the buzzer, and a 4-digit 7-segment display. In the upcoming videos, I will explore each part of the project in more detail. We will cover digital outputs, polled inputs, interrupt-driven inputs, ADC conversions, PWM generation, 7-segment display multiplexing, UART debugging, and other useful STM32 concepts. If you found this video useful, please give it a like and consider to subscribing to the channel. If you have any questions, suggestions or ideas for future STM32 experiments, please leave a comment in the field below. The project is also uploaded on my GitHub account, so if you're interested, you can take a look for it there. So until the next video, stay safe. Bye.